Now, let us visit some basic definitions about probability as it relates to the most commonly used concepts in statistics. Essentially, probability is a measure between 0 and 1 for the likelihood that something or some event might occur. For instance, you may hear that the stock markets, the chance of stock markets rising above some point or falling below some point is X%, or you may hear that the chance for rain is 45% tonight. These are all coming from this very concept of probability. Essentially, probability is a measure between 0 and 1, so 45% would be 0.45. The discussion about probability is not complete without a discussion about random variables. Essentially, a random variable is a quantity whose possible values depend in some clearly defined way on a set of some random events. It's a function that maps out outcomes, that is, points in a probability space. So probability space essentially is all possible outcomes. If you roll a die, it can have 1 out of 6 outcomes, so that's the probability space there. If you roll 2 dice, you can have 1 out of 36 outcomes, where each outcome could be considered a random outcome. And a probability distribution is a theoretical model that depicts the possible values any random variable may assume, along with the probability of its occurrence. We'll define this more with examples using 2 dice. So consider 2 dice. A die has 6 faces. If you roll 2 dice, it can assume 1 out of 36 discrete outcomes. If you were to roll 2 dice, the probability that both die would have 1 as the outcome would be 1 plus 1, 2, and there's only one possibility of getting that, and that's 1 out of 36. So here we have 2 die, 1 black and 1 white, and if you were to look at the possibility of getting 1 on black and 2 on white, that's 1 outcome. So that's 1 plus 2 is 3, or you can have 2 on black and 1 on white, that's 2 plus 1, 3 again. So there are 2 ways of getting 3 by rolling 2 dice. So the outcome or the probability is 2 out of 36 possible outcomes that are mapped out here. So if you think about the sum of 2 dice being 2, there's only one possibility out of 36. Getting a 3, you have 2 possibilities. Getting a 4, you have 3 possibilities. Getting a 5, you have 4 possibilities, and so on and so forth. The maximum, most frequently possible number to have as a sum of 2 dice is 7, and the probability is 6 out of 36, which is 0.167. And if you were to sum these probabilities up, that is 0.02 plus 0.056, you get 0.083. So if you sum up all these, they all sum up to 1, and the probability of getting 6 or less than greater than 6 is 0.58, or getting less than equal to 6 is 0.417. You sum these up, it's 1. 0.028 plus 0.972 is 1. This plus this is 1, this plus this is 1, and obviously 1 plus 0 is 1. The probability of getting 12, that is, both die show 6. There's 1 out of 36 possible outcomes, which is 0.028. So the probability sums up to 1, and the probability of getting more than 12 is obviously 0, because the 2 dice can maximum produce this number. So nice way of looking at the way a probability distribution space is created by rolling 2 dice. And if I were to look at the probability of, say, getting some number or less than some number, that's called the cumulative distribution function. If you were to simply chart this probability outcomes in a chart, you get this graph here. So here we have age as our variable, and I created a histogram of age, and then using the mean value of 48.37, which is the mean average age, and a standard deviation of 9.8 years, I can fit a theoretical normal distribution with these 2 parameters.